My name is Sue DeGram. I'm a Marketing Director here at Adaptive Computing Enterprises. Today our webinar is going to be about how to use Adaptive Computing's on-demand data center. So thank you for joining us today. I have with me Dan Canoni. He is Manager of Sales, and Reinventor, who is a Senior Solutions Engineer, and then John Seepley, who's Director of Development, Support, and Services, all here for questions while we go through the webinar.
I'm Dan Canoni. I'm a member of the sales team here at Adaptive Computing. I'll give you a quick overview of Adaptive Computing, and then we can jump into a live demonstration. Adaptive Computing is a trusted leader in the high-performance computing and enterprise software space, more specifically HPC workload scheduling and cloud solutions. We've been pioneers within the high-performance computing and cloud spaces, and we've been at this for more than a decade. On this slide, you can see some of our industry verticals. We work with a lot of customers within the oil and gas space, the government space, automotive, financial services, weather. We work within the enterprise and HPC spaces, and some of those use cases include hybrid IT, DevOps, machine learning, AI, big data, and other HPC GPU areas. Adaptive Computing has an extensive customer base. We have over 200 plus customers in the world's most demanding IT environments, a lot of Fortune 500 companies, government entities, and universities across the globe. Now I'll jump into the on-demand data center solution. I'll give you a quick overview. We can look at an architectural diagram and then jump into the live demonstration. The on-demand data center gives companies the ability to spin up temporary or persistent data center infrastructure quickly, inexpensively, and on demand. We exploit the full advantages of cloud resources and the flexibility of using multiple clouds to spin up your infrastructure. Teams can automatically deploy and build clusters in the cloud directly from our interface. They can do so automatically or manually, and they can terminate these resources on a daily, weekly, or even hourly basis. This all becomes extremely useful to organizations to give out access to our interface on a temporary basis. For example, an organizational project, creating a temporary workspace where they can take away access when the project is no longer needed. Within our interface, you have access to every major cloud provider. They all come pre-configured and built into the easy-to-use user interface. All you have to do as an administrator is bring your cloud credentials. Some of the main features of the on-demand data center include the ability to build and customize your stacks. A main stack comes pre-configured within the solution. It allows you to spin up your resources on any of the major cloud providers. As I mentioned, you can customize your stack for specific software requirements that you have. This also allows you to spin up resources and pull data from external resources as well if your data is not located in the cloud. As I mentioned before, creating temporary workspaces, we can share clusters across users on the platform. You can collaborate if there's a specific organizational project and you need to give users access to a cluster that has specific hardware types. You can share that cluster among user groups. There's automated infrastructure provisioning. When we deploy infrastructure within the cloud through our interface, we provision all needed software components to run your workloads. Our application deployment creates portability for your organization, the ability to deploy resources on multiple clouds and run your applications across multiple cloud providers. Gives you the flexibility and portability just in case you need to move your workloads to another provider. For example, if pricing changes on one provider or your relationship with a provider goes south, or you just want to take advantage of specific hardware types on another cloud provider. We give you the ability to auto-deploy CI/CD pipelines directly through the interface. This is beneficial for the deploy phase of a pipeline. We will spin up infrastructure for you. You can test your code and you can tear down these resources automatically. This also plays into just general automation testing, allowing you to spin up resources, run tests, and then tear down these resources. The main benefit of doing so for a CI/CD pipeline all plays into our cloud bursting ability. This gives you the ability to spin up resources, and we will spin these resources up based upon your workloads and then tear down these resources when you no longer need them, saving you costs associated with not using resources, not paying for resources when you're no longer using them. We can also cloud burst from on-premise resources. If your on-premise resources are being fully utilized, we can send the backlog workloads to the cloud and to our interface. This all plays in with our general ability to schedule and orchestrate HPC and enterprise workloads. We manage non-homogeneous compute resources, and demos can be tailored to your organization's specific needs. So please reach out to us with your specific requirements, and we can follow up with a more tailored discussion after the live demonstration. And then here are some customers using the on-demand data center. We have a European-based multi-country metrology company providing public cloud compute resource pools to their large scientific and shared technical services user community. This is a community of over 2,000 users. Another customer is a multinational quantitative investment management company headquartered in the USA. They use the on-demand data center solution to model financial risk within their organization. And third customer is a multinational HPC oil and gas application provider. This customer embedded our solution into the back of their application user interface. This allows their customers the ability to seamlessly spin up cloud resources to run their workloads without needing any technical cloud knowledge.
I'll do a live demonstration for you guys today on the on-demand data center solution and go over the diagram just to start. The goal of today is to give you guys a high-level overview of the solution. And then if you guys need any deeper technical review or more tailored demonstration, we can reach out and set one up after the webinar and go from there. So to start, we just wanted to show you the architectural diagram for the solution. As you see here on the left-hand side, we have users sitting at workstations, building workloads, either submitting workloads via the job submission portal that you'll see in the live demonstration or via a desktop application. And those go into a main queue, which are then sent to our overall solution. The solution can spin up resources in any of the main cloud providers. You can see 6 of them on the right-hand side: Google Cloud, AWS, Azure, Oracle Cloud, IBM Cloud, Open Telecom Cloud. If there's a cloud provider you would like to work with and you don't see there, let us know, and we would love to include that cloud provider into our solution. We pre-configure all of the needed software to run your workloads onto deployed clusters within our solution. So when a user submits a workload to the queue, all necessary software components are already pre-installed on the clusters, and we can run those workloads in any of the given cloud providers. And we'll jump into the demonstration and show you the flexibility of being able to spin up resources in multiple cloud providers all through our main interface. So we'll dive right into a live demonstration and just switch screens. Excellent. So right now you can see that we're signed in, but we're going to sign out for you guys just so we can show you the login page. So we went over the main diagram, but now here we are on the web-based interface. We're just going to sign in with the username and password. As an organization, you can give out username and passwords to different members of the organization, and they can have their own individual account, or they can use shared accounts across departments and kind of split up the logins from there. What we're going to show you to start is we're going to show you the deployment of resources in 2 different cloud providers to show you the flexibility of being able to switch providers right through the interface. In order to spin up cloud resources in AWS, it's as simple as clicking on the deploy button on the right-hand side and then clicking on the AWS logo, and then you have the cluster deploy screen. An administrator just has to bring a cloud provider credential file and have that pre-configured into the interface. But as a user doesn't need to bring a credential file, so just the organization credential file needs to be pre-installed within the solution. And as a user coming into the platform right now, we can go ahead and create a cluster in AWS, having our credential file already in the system. We can click on the region that we want to spin up resources in. So here we'll select US East 1. Actually, we'll do it in US West, and then be able to select the availability zone within US West 2. We can go into more advanced settings and select the head node size, and then size up our cluster with the compute nodes that we want included. All of the instances that you see here on the drop-down are all of the available instance types through AWS. So we can come down to the compute nodes and select what compute nodes we want to consist within our cluster, and we can size up this cluster according to how many instances that we want included. and then we'll close out of this. And what we want to do is we're going to jump right into the AWS cluster and just show you what the configuration looks like. For the purpose of the demonstration, we already configured a cluster in AWS. As most of you know, it takes about 5 to 6 minutes to spin up resources in a cloud provider. So to save us that time, we pre-configured a cluster. And we'll dive right into the configuration section of this cluster. And we can look behind the scenes here and see that we have a T2 medium node currently available within this AWS cluster. We can have a brief description of this cluster on the left-hand side, see where it's located, see the cluster IP. So from here, we want to show you how easy it is to then take that same kind of cluster configuration and spin up the resources in another cloud provider. Benefits of this is if AWS changes their pricing, your relationship with a particular cloud provider goes sour and you want to switch cloud providers easily. Or number three, the most popular reason of doing so is every provider obviously has different hardware types available. If you want to take advantage of a particular GPU in Azure or IBM Cloud, you can spin up resources within those providers and have a CPU cluster available on AWS. So you're always taking advantage of the best hardware currently available in the market. So we'll go back to the main screen and show you what it takes to then go into a different provider and spin up resources. So you click deploy, similar like we did to AWS. We click on a different provider. We'll select Open Telecom Cloud. It's a cloud provider out in Germany. And we'll do the same like we did to the AWS cluster. So we'll name our cluster, click on a credential file, select the head node size. These are all the instances currently available within this cloud provider. We'll select our region, availability zone, and size up our cluster according to whatever configuration that we want readily available. With both of these clusters, we spun up resources that are going to stay online until we take them down. So both of these clusters, if you went behind the scenes into your cloud provider consoles, you'll see that the instances are currently available. So why don't we do that right now with the AWS console we currently have online. So we'll click into the AWS console. And as you see here, we're in the AWS console, and we spun up that AWS cluster, and the node that we spun up is currently available within our console. So we'll go back to our interface. Just wanted to show you that there. And an additional benefit of being able to spin up the resources directly in our interface is, as an organization, you don't have to give console access to any of your users. That's an extreme benefit because the consoles are obviously complex, and a lot of times users are afraid of clicking behind the scenes and changing any of the organizational settings that you currently have within your provider. So everything is done through our interface. You just have to give your users the login, like I said, and have an administrator have the credential files ready to go. So right now we have the two clusters currently available. We have the cluster in AWS and the cluster in Open Telecom Cloud. So now as a user, let's look into how we would get a job ready and submit a job. So there's a job submission portal right within our interface through the job manager. We have a current MPI job example, obviously familiar if you're within the HPC world. To configure this job and get it ready for submission, we can name our job and we can go into the script and we can attach a custom script ready to go. And then we can include any data files needed to run this workload. So we'll close out of that. So as an example, we'll take this job that we currently have in the job manager and we'll submit it to both of the clusters we currently have available. So we'll select the AWS cluster right there in the dropdown. And then we'll go back and submit that same job to the Open Telecom Cloud cluster we currently have available. Excellent. Excellent. So we've submitted both of these jobs to the two available clusters that we have. Now as a user, you can view all of your output directly within our interface. If you're using our solution as a cloud-first model, a cloud-only model, all of this output data doesn't have to leave the cloud, which is a wonderful tool. So we'll click into the file manager here, and we'll click on the drop-down and click on one of the clusters that we currently have available. So there it is, the top job. We have the output for the MPI job we just ran, and we can view that right within the file manager. Excellent. And then if we wanted to view the output for the job we ran on the OTC cluster, we can click on the OTC cluster on the top right-hand side, view the output data. here we are, all within the interface. Excellent. And what we'll do is I'll show you how that works on the cluster manager page. Let's dive into one of the clusters. We'll go into the AWS cluster and show you kind of behind the scenes of what's happening. We already went into the configuration page, but when the job was submitted to the AWS cluster, it gets submitted to the AWS cluster queue, as you see on this screen right here. So if there's multiple users submitting jobs to this one particular AWS cluster, they would be queued up and then submitted to the cluster when resources are available. You can click on the nodes screen and you can see the available nodes. So this is obviously helpful if you have a large instance currently available and a couple jobs taking up space on that instance. You can see the breakdown of cores being used. And then this is just the main cluster page, so you can see all the jobs submitted, the jobs that are currently in the queue, and then the nodes that are available. And then we'll just go back to the main cluster manager page, and I wanted to touch on a very important feature that the product has. It's a feature that we call bursting. So it's bursting within your cloud environments. Currently right now we have 2 available clusters in AWS and Open Telecom Cloud that have resources that are turned online and will be online until we take them down. However, if we configured a bursting cluster, the cluster will be available within our interface, but behind the scenes in your console, your cloud provider console, those resources will be offline. So you're not paying for those resources. When a job is submitted to one of those clusters, our solution will go into your console, provision those resources, take them online, run the jobs that are currently in the cluster queue, and then once that job has completed, we will tear down those resources. So you're only paying for cloud computing resources when jobs are within the queue. And you can configure clusters to meet particular workload requirements within your queue. And this is an obvious cost control for an organization. You're not paying for resources and you're not leaving for resources online when you're not using them. This is a great feature of the product. A second feature I wanted to touch on is, as an organization, temporary workspaces. As you saw, we logged into the interface with a username and password. As an organization, you can give users short-term access to the interface. If you want to have a project that a user needs computing access to for 2 to 3 months, you can give them access to the portal for that time period and then take away their access after their project is done. And you can also collaborate across clusters with different users. So you have say there's a departmental project that you're working on, and you want to include multiple users that have access to a particular cluster in a cloud provider. So I, as an individual, can come in. I can create a cluster in AWS or a cluster in Azure or a particular cluster that has a particular GPU for the project that we're working on or a particular instance type. I can come in, create that cluster, and then add in a bunch of users from my department who also need to collaborate on that project. So we can do so here. You can add them in. So that's a wonderful feature. The last feature I wanted to touch on is the different deployment models of the solution. So as you see here, this is a cloud-only deployment model where we signed into the interface and we spun up resources that are only consisting within the cloud. But our solution is incredibly flexible in the way that we can have our solution currently run in the cloud as we see here, but we can integrate with on-premise resources. So say you have a backlog currently on-premise, or your on-premise resources are being fully utilized during times of surge. We can take that backlog and we can send that backlog to the queue for our solution here and configure resources in the cloud to run those jobs when the on-premise resources are being fully utilized, run those jobs, provision resources, tear down those resources when the jobs are done running, and then send the output back to on-premise for your users. So that's a wonderful tool to create overall elasticity within your on-premise and cloud environments. That's one deployment method. The second was the cloud-only deployment method. And then the third is just an overall hybrid deployment method of having an on-premise system and then having a cloud system through our interface deployed at all times, ready to go, ready to accept workloads, and not having it in a bursting model within the cloud. So you're paying for those resources throughout the duration of having them online, and then you tear them down as an administrator or as a user when you no longer want to use that. But the main benefit of our solution one that a lot of customers take advantage of is the bursting model for the clusters, being able to only deploy resources when you need them according to workload requirements in the queue, and then tearing those resources down when you no longer need them. But from there, I hope everyone got a glimpse of a high-level demonstration of the platform, of how to come into the platform, sign in, create a cluster within multiple cloud accounts, taking advantage of multiple cloud providers, taking advantage of being able to spin up on-demand computing resources, flexible to your current needs, submitting a job, seeing the output all within our interface, and then hearing some of the additional benefits and additional features of the product. As I said, this is a high-level demonstration. If you want a more tailored demonstration and get a little more technical and understand how our product meets your particular use case or requirements, please reach out to us. We can have a demonstration, a live demonstration for you, a more tailored approach and a more tailored conversation. So we look forward to hearing from you, and I'm going to pass it back to Sue. Thank you.
Great, awesome. Thank you, Dan. That was great. So right now, we'd like to open it up for questions. And so I think that everyone should be able to either send a chat or ask a question. I believe that everyone's unmuted. Ah, I see one in here. Okay, Scott Fast. What messaging feeds do I receive as a job is starting, running, ending?
All right, so maybe I can take that question. So I'm assuming what you're asking is what kind of messaging feed, meaning when it starts, runs, and ends, as we mentioned and showed while you're on, when you kind of, let's call it, drill down into your cluster details. You can see the overview from a dashboard point of view. It shows what's currently running, which nodes are actually busy. Also, we have got the job queue that actually shows you the active jobs, whether they're busy running, whether they're completed, and if a job is actually waiting in the queue. As Dan explained, if you've got bursting on, it will remain in your job queue, waiting for a node to become available. And then it will go into a active state that is busy running. And this is on your job itself and also on your node side as well. When you utilize the bursting functionality, on that screen actually it will actually show you when a node is actually busy deploying. So it's all visible. So you'll see the kind of information. From a if you're talking about messaging, meaning visibly seeing it. Obviously, we keep all this information in the background. Obviously, we use certain types of databases and so forth. If that's a requirement in the sense of putting information about what has run previously. On our job queue, we've got variables that you can make use of. By default, it gets rid of it after 5 minutes. I like to do it sometimes to keep it for 24 hours so that you can go back what has run over the last few days. So that's an option. We can switch that on for you.
Okay.
So yeah.
All right. So Dan, I'll let you read this question.
Yeah, I'll take the second question from Scott. He's just asking if he can set up some form of messaging outside of the console when a job is completed or running or starting, and that's no problem. We can currently set up email notifications. Excellent. Yeah, John, why don't you take this?
Yeah, one of the things too is any command you see that was run to be able to schedule a job and run a job and monitor a job from the UI are also available for every user that is, they have a shell login also. So we can run commands like qstat, PBS node, show what's active out there on a node. And you could always put those into a cron job to currently schedule it. We don't have any emailing facility as of yet. Nobody really asked for that capability, but again, incorporating command line tools that every one of these commands use to kind of look at the queue, look at the jobs being run, look at the output, could be put up into a cron job situation. So you could have a script that can run to process your information that you need.
Dan, question. How long does it take somebody to get set up to actually move some of their workloads to the cloud with this product?
Sure. I mean, we have a very clear and defined quick start guide and installation guide to get you set up. You can install the server on premise or in the cloud. Say you're going with the cloud only model. It's a quick installation within your cloud environment. You can host it within your AWS account, for example. And then it's just as simple as creating your overall stack and including the needed software packages for the applications and workloads that you want to run. And then going into the job submission portal and readying your jobs for submission. And going from there. The first step after that, so it's very quick. I mean, you can be up and running, within a few hours, as long as you have your cloud provider access. As I said before, the one step that you need is a cloud account. So, to get set up, you just need the credential file. And a great benefit that I mentioned earlier is it's just an administrator needs your organizational credential file. So every user doesn't need access to a credential file. Once it's pre-installed into the system, any user can log in and be ready to submit their jobs to the system.
Okay, great. Thank you. Okay, I do not see any more questions, but please feel free to email us any questions or give us a call. You can contact Dan directly at 239-309-0096 or at dcanoni@adaptivecomputing.com, and he will be happy to answer any other questions that you might have. Also, please visit our website and check out the On-Demand Data Center for more detailed resources. I'll be sending out a recording of this presentation to everyone, and you should be getting that by tomorrow. So thank you once again for joining our webinar today, and please have a great rest of your day. Thank you.